Hi everyone, welcome back to another practice question on vectors. This is taken from the ACJC 2018 Prelims Paper 1, question number 3. Now in this question, we would like to prove that PQRS is a parallelogram, and PQRS are the midpoints of A, B, C, D. Now there are several ways to prove this. To start off, we can do a quick sketch of the diagram to better visualize this problem. In order to prove that PQRS is a parallelogram using vectors, we need to either show that vector SR is equals to vector PQ, or we can show that vector RQ is equals to vector SP. Now this would mean that they are not only parallel, but the pair of magnitudes or the length are the same. So let's take the pair vector SR and vector PQ. In order to prove that they are equal, let's try to work backwards to see what ingredients are needed. Now to get vector SR, we need vectors OS and OR. So we're going to find them right now using the midpoint theorem. Vector OR is vector OC plus OD over 2. And similarly, vector OS is OD plus OA over 2. So vector SR will then be OR minus OS, which is OC plus OD over 2 minus OD plus OA over 2. And simplifying, we will have OC minus OA over 2. Now let's try to get vector PQ as well. We are going to need vector OQ and vector OP. Now, using the midpoint theorem, vector OQ is equals to OB plus OC over 2, whereas vector OP is equals to OA plus OB over 2. Thus, the vector PQ is equals to OB plus OC over 2 minus OA plus OB over 2, and is equals to OC minus OA over 2. Now you can see that since vector SR is equals to OC minus OA over 2 and is equals to the vector PQ, we can safely conclude that PQRS is thus a parallelogram. Now to approach such questions, remember, number 1, establish what we need to prove in order to get a parallelogram. In this case, we need to prove that a pair SR and PQ are equals to each other. Number 2, work backwards and gather the necessary ingredients required for the proving to take place. Now let's move on to part B of this question. At one glance, usually we will always make use of the algebraic properties of the scalar product for vectors. Now we are required to find the exact values of k by considering 3a plus c dot 3a plus c, and given this set of information in the question. So let's try to first expand vector 3a plus c dot 3a plus c. We will then have 9a dot a plus 3a dot c plus 3c dot a and plus c dot c. Now since 3a plus c is equals to kb, what this means is that kb dot kb is also equals to 9a dot a plus 3a dot c plus 3c dot a and plus c dot c. Now simplifying, we will have 9a dot a plus 6a dot c plus c dot c. Now it is at this point we can employ the algebraic properties of the scalar product. We can first extract the k, so k square multiplied by modulus of b square, because b dot b is equivalent to modulus of b square, is equals to 9 modulus of a square plus 6. In this case, we are going to use the scalar product, which is modulus of a, modulus of c, cosine pi over 6, because angle AOC in a question is pi over 6, plus modulus of c square. Now, in the next step, we can then substitute the values that are given in the question into our expression. K square b square is equals to 9 multiplied by 1 plus 6 multiplied by 1, because the modulus of a which is a unit vector, is 1, and the modulus of c is square root 3 cosine pi over 6 plus root 3 square. Now simplifying, we will have k square multiplied by 3 square is equals to 21. To find the value of k, all we need to do is to divide 3 square. So k is equals to plus minus square root 21 over 3. Now I hope you do learn something from this video. If you like this video, do hit the subscribe button so that you can see more valuable content such as these. Thanks for watching.